Hello and welcome to CET 4884. After addressing the software and hardware requirement to secure organizations' information, we need to address the importance of securing the organization assets physically. Having firewalls or IDPSs will not work or will be defeated if someone managed to physically be inside and was able to access the information internally, to access the server or get to the server internally. It's very important to address the physical security considerations for selecting a facility site, location, the building, doors, walls, everything that's related to the building itself. Also, identifying physical security monitoring components. Do we need cameras? Do we need other measures to monitor the facility or the building? And then describe the components of fire detection and response. We will talk all about that and more in this chapter. The physical security addresses the design, implementation, and maintenance of countermeasures that protect the physical resources of an organization. And when we say physical resources of an organization, not only the devices or the hardware, software, but also the people that can hold information in the organization, scientists that know additional information. So we need to make sure that they are safe and in a safe environment. Physical access to the devices or to those people can affect the company. So as I stated before, most of the technology-based controls discussed to this point can be avoided if an attacker can gain access, physical access to the devices or the people being or hold information inside. Some computer systems are constructed in such a way that it's easy to steal the hard drive and the information it contains. Most of the new servers are hot swap. You can just pull the hard drive while the computer is working, and all these hard drives they have lots of information. So once you take the hard drive out, that's it. Or if you have an external backup hard drive, you can just disconnect the USB connection, take the hard drive, and take all the information. So when you are inside the building, you can do any damage because physically actually you are in. So you can do damage for the organization or the information system. As a result, physical security should receive as much attention as logical security in the security development life cycle. There are 7 major sources of physical loss. The extreme temperature, whether it's heat like a fire or cold, if it was very cold to the limit that it will freeze the equipment or devices that's working. Gases, war gases, commercial vapors, humid or dry air, suspended particles, all that will affect the machines if something happened like that within the building. Liquids like flood, water, or other chemicals, the spill of other chemicals within the building might affect the wiring, might affect the devices or the workstations, and could affect the information system. Living organisms such as viruses, bacteria, people, animals. Again, some of the people that can disconnect or sabotage the organization from the inside, that will be a problem. Or animals like rats that can chew on the wiring and disconnect the network from the outer world. Insects also might affect, like termites might affect the structure of the building, which might lead to a collapse or something related to that. Projectiles also can affect the information system physically. We are talking about tangible objects in motion or powered objects. Movement such as collapse or shearing shaking, vibration, liquefaction, flows, waves, separation, and slide. All these are natural disasters that happen because of either extra rain, lots of rain, or because of an earthquake. All these natural disasters could happen, and that will affect the building and the structure of the building and the information system. Energy anomalies, electrical surge or failure, magnetism, static electricity. Um, if we have a huge magnet that can come close to the server or to the information, it can wipe the information. Aging circuitry, maybe the circuit that we have for the building is very old, that cannot handle the uh, pressure of the electricity coming from the servers or the machines, which will at the end it might affect the power that's going to these machines and then lose the power. The sound, light, radio, microwave, electromagnetic, atomic, all these are energies that can affect the information system, and we have to be careful when we build the facility or when we select our facility that it will be protected from such energies. So what's the community roles? If we look at the different organization uh, classification or levels of management and interaction with information systems or information technology, we can say that we have three main levels: the general management, the IT management and professionals, and the information security management and professionals. So for the general management, they are responsible for the security of the facility in which the organization is housed. And of course, they are responsible for the policies and standards for secure operations. The IT management and professionals, they are responsible for environmental and access security in technology equipment, locations, and for the policies and standards of secure equipment operations. For information security management and professionals, perform risk assessments and implementation reviews for the physical security controls implemented by the other two groups. To secure facility, um, let's say before examining access controls and uh, the facility, we need to understand the concept of securing the facility and its design. From the point of view of facilities management or facilities manager, a secure facility is a physical location that has been engineered with controls designed to minimize the risk of attacks from physical threats. A secure facility can use the natural terrains. For example, it can be on top of a mountain to limit the access to that building or to that location. Um, um, Look at the traffic flow, be in an urban development, um, can complement these features also with protection mechanisms such as fences, gates, walls, maybe guards if needed, and alarms, cameras. We can add anything to secure the location, the building, the facility itself, and the room that holds the information. So if you look at that, you are actually looking at securing the facility in all, like the whole location that the organization exists in. So you will have a fence and a gate for that to access. And you will have we are going to talk about the different ways to access just the gate outside. You can put a guard to check on IDs, or you can use magnetic IDs to get through. Then another gate at the building itself or in the building itself. Then another access point or control point in the server room. Not everybody can go in the server room. So all these are considered as physical security measures that can be taken to secure the information within the organization. So again, we are talking about the walls, the fences, the gates. We are talking about using guards to protect the gates or these access points. Um, also, dogs to make sure that we don't have anyone that will pass, even the guards that we have. Um, ID cards and badges. Everyone should have an ID. Everyone should have a badge, so we will know the employee from the non-employee. If we have a guest that's entering, do they have permission, and how would that work? The locks and keys for the offices, for the different rooms that we have in the building that holds information. We have different locks, different mechanisms for the locks, and different measures for the keys. We will have man traps, and we'll talk about the man traps. We will have electronic monitoring. We will have alarms and alarm systems. We will have computer rooms and wiring closets. We'll talk about how we can secure the computer rooms and wiring closets, and then the interior walls and doors. So for the ID cards and badges, one area of access control that ties physical security with information access control is the use of identification cards and badges. An ID card is typically worn concealed, whereas a name badge is visible. These devices are forms of biometric, could be like facial recognition to identify and authenticate and authorize individual with access to the facility. With the addition of a magnetic strip or a radio chip, the ID card can provide access control. You can just slide the card and get in the room or the building that you are in. For the name badge or ID, it should not be the only control for access to restricted area, as they can be easily duplicated, stolen, and modified. You can see that in movies where someone can just take the ID of another person and use it to get in, especially if they look the same, or they can change the picture. They can just duplicate the ID and get into certain places. For that, you add other measures like fingerprints or the hand or the retina, or other measures, just to make sure that this person can get in, or is authorized to get in the area that holds information. In some cases, the hackers or the attackers will tailgate the authorized individual or personnel. For that, you will see that some of the doors are designed in a way that it will allow only one person at a time to enter the building, and it will not allow the next person after that. So that's another way to control the tailgaters from getting in, or the hackers or the attackers from getting into the building. For the locks and keys, there are two types of locks. Actually, I think there are more than that. They have the mechanical and electromechanical. They have the magnetic now. They have lots of locks. And for those locks, the mechanical lock relies on a key of carefully shaped pieces of metal that turn tumblers to release secured loops of steel, aluminum, or brass in brass padlocks. The electromechanical lock can accept a variety of inputs, including keys that are magnetic strips on ID cards, radio signals from name badges, or pins typed into a keypad. Locks are divided into four categories. There are manual, programmable, electronic, and biometric. As part of the general management responsibility for the physical environment, the management of keys and locks is a fundamental concern. Sometimes locks fail and facilities need alternative procedure for access. So when locks fail, there is one of two ways. Either the lock will fail and the door become unlocked and anyone can get in, or um, it could be in a fail safe lock. When the lock of door fails and the door remains locked, this is actually it's the other way around. So when the door fails to lock and becomes unlocked, we say that it's called fail safe. So fail safe, that means it's unlocked, it stays unlocked because it fails to lock. And when the lock of a door fails and the door remains locked, this is fail secure lock, fail secure lock. Now the problem whether it stays unlocked or stays locked, there should be a procedure or a process, like a manual process, to override this and either lock or unlock the system. You cannot keep that room unlocked or you cannot keep it locked, so you have to have some kind of a procedure to override this problem. Those are some of the like snapshots or photos of different locks. We can see the programmable, the electronic, the electromechanical. So all these are different types of locks that's been used within organizations just to secure the information or to secure some of the rooms. Mantrap. The mantrap is a small enclosure that has an entry point and a different exit point. The individual entering the facility or area or room enters the mantrap, request access through some form of electronic or biometric lock and key, and if verified is allowed to exit the mantrap into the facility. So we add this room in the middle, whether it's before the server room or before the whole facility or the whole department that we want. There is like a hallway or a big room. If the person that entered that room authorized, then they will go through and go to the main facility. If they are not authorized, they are trapped in that area and they will be denied entry, and they're not allowed also to exit until a security official overrides the automatic locks and capture the attacker that was trying to get into the system. And that's why they call it Mantrap. Actually, this is a photo for, or a snapshot for, the Mantrap, and as you can see, we have a hallway with entry, and they will not be allowed to exit unless they have the permission or the authorization to do that. So they will be trapped in this hallway until security comes and get them. The electronic monitoring, it uses it used to record events within a specific area or areas where other types of physical controls are not practical. Monitoring frequently uses cameras viewing individuals, while on the other end of these cameras are video cassettes, recorders, and related machinery that captures the video feed. Now, the video cassettes there that was very old. Now they are using actually digital videos that can be saved on a DVR, and the DVR can be overwritten every like month or every certain period of time, so they will have space on that machine. It depends on the policy of the organization, and how long would you like to save the recording for these videos. It could be up to 6 months or a year or 3 years, just to make sure that nothing happened within that period of attacks or threats. These systems have drawbacks, as for the most part they are reactive and do not prevent access or prohibit activity. You can see the people, you can see the attacker, but you cannot do anything, because unless you dispatch someone, unless there's someone there to stop them. If you are monitoring from a remote area or far area, then you cannot do anything except just setting the alarm that someone or there's an intruder in the area. The recorded monitoring requires an individual to review the information collected to make sure that the recording is viewed correctly, or is covering the required area. Those are drawbacks that now with the new systems that's coming out, they are addressing these problems, and it's not needed anymore. Actually, it can set certain measures and lock doors and prevent people from leaving or going in certain area. So that's been addressed in the new system. It's like integrating the monitoring system with the locks, where as soon as they see someone in the area, it will lock the door, all the doors, and keep them in certain room that will not affect the information systems in the organization. Alarms and alarm systems. The alarms or alarm system notify appropriate individuals when a predetermined event or activity occurs. If a hacker, if an attacker, or a threat came to the facility, physically to the facility, then an alarm will be set, and it will notify via email, via text, that an intrusion happened. This could be a fire, a break-in or intrusion, an environmental disturbance. It could be a flood. It could be interruption of services, or even a loss of power. You will receive a notice that the power got lost. Um, you need to do something about that. In certain places, you will have power generator that will kick in immediately. In other areas, you just wait, or you can call someone to take care of the problem. The burglar alarm systems detect intrusions into unauthorized area and notify either a local or remote security agency to react. If you have security people on the premises, they can be dispatched, or you can connect your system with the police department, and they will send someone to take care of the problem. These systems rely on a number of sensors that detect the intrusion. The motion detectors can detect any intrusion, and they can set an alarm. Some of them also thermal detector. By the heat, the human body heat, it will be detected and it will be sent to the monitoring system or to the alarm system and trigger it. The attacker could break glass to be able to get into the building. That also will have sensors that will be sent to the alarm. The weight sensors and contact sensors, all these are sensors that can be used to send the information to the proper authority. The computer rooms and wiring closets. The computer rooms and wiring and communication closets are, facilities that require special attention to ensure the confidentiality, integrity, and availability of information. You are trying to secure the information, but at the same time, you are trying to make it available for the people that's authorized to use it, which will be very hard to do. So the logical access controls are easily defeated if an attacker gains physical access to the computing equipment. Um, One of the most dangerous situations is the custodial staff, which are often um, have authorization to get into many areas that could be sensitive or hold sensitive information. Um, they have a lot of access to many areas. At the same time, they are unsupervised for that access. So um, the degree the degree of supervision has to be increased for the custodial staff. The interior walls and doors. The security of information assets can sometimes be compromised because of the construction of the walls and doors of the facility. If the uh, servers exist in a room that has just a drywall or a wood wall that can be break in, anyone can break in that wall and get into the room or the facility. This is one thing. The other thing is the uh, fear of fire. So if there is a fire with a drywall, also it can get to the information system or to the um, organization server or to the place where the information is. So usually these walls are typically uh, like firewall or fire resistance. The same for the doors, they are fire resistance. They can keep fire away from the server or from the information. All high security areas, such as computer rooms, wiring closets, must have the firewall grade walls surrounding them. Uh, Usually it's blocks of concrete, can hold a high temperature without any problem, cannot be penetrated through punching or through um, easy access by breaking in through this wall. Some of them, even if you try to use like gun or other ways of breaking in, it will not work. This provides not only physical security from potential intruders but from also fire as well. So the doors that allow access into these types of secured rooms should also be evaluated, and all should be fire resistance. Uh, they have these computer rooms, they have also push or crash bars installed in case of a collapse for the building. The building can collapse, but that room will hold the information without any problem. Um, Such devices meet building codes but provide much higher levels of security than the standard door pull handle. So we have lots of, you know, designs that we need to consider when looking at the walls and the doors of the um, server room or the wiring closet. That will be all for this session. If you have any questions, you can either email me, call me, or Skype. And, of course, you are most welcome to come face to face. Thank you and have a great day.